Hello, this is Todd Travis with Texas Monoline Systems. We are an engineering firm that specializes in solutions for the oil field. And we have, in this time of COVID, have shifted our uh, thoughts to green energy and have come up with several patents pending items that we think will aid in the future of the oil industry. In doing so, we have run some of our ideas past Chevron and BP, and both have agreed to give us field trials when we have our prototypes ready. The concept that we have developed is that in a Christmas tree or a gas well situation, you typically run the gas up and through the wing valves onto a choke. That choke takes the pressure from 7,000 psi down to some usable amount, that being 1,000 psi or less. And in doing so, we release energy, and we don't use that energy, we just burn that energy off. So if we can replace the choke with a motor, an air motor, or, and in the situation of an oil well, a hydraulic motor, we can make thousands and millions of kilowatt hours and put them back to the grid and produce electricity at a much lower cost than is done today by burning those same fuels. In this case, we will not be burning them, so we are a clean energy. We are only allowing them to flow or expand. By using the combined gas law, we can calculate the amount of kilowatt hours that could be produced just from the expansion of the gas in a gas well. However, we can probably produce more than this by creating a longer moment arm for that same gas. But in just using the thermodynamic properties through the combined gas law, we can calculate what we can produce. So we used the Omni calculator, and you can see the link there. Omni produces 1,445 various calculators for various things, so I want to send a plug out to them. They are a very good place to source all of your calculators, both engineering and economic and everything else. But using their calculator, we can produce 1 million cubic feet, and we can sell that 1 million today on the market for $3,160. That would be revenue on the New York Mercantile Exchange or in many places around the world. And assuming that the cost of the well and the pipelines and the transmission and the cleaning is 75%, you can produce a profit, a 25% profit of about $790 per million CFM. If we take that 1 million cubic feet at 10,000 psi, before we run it through the choke, we can produce 9,362 kilowatt hours or $936 of revenue, and we can profit about 50%, which would be $468. So through our patent system and through our products that we're going to offer, we can aid in a gas company or a oil company to produce, instead of their typical 25% or 30% profit, we can supplement that profit with that same gas or oil before it comes out of the tree, or as it comes out of the tree, with about another 50% of profit that is just sitting there waiting for someone to capture it. Right now it dissipates into the choke and we lose it forever. We can also do this in gas storage wells. We can do this in pipelines. We can do this in many other pressurized systems as long as you are either flowing and or depressurizing the media. One of our patent pending items, just to give you an idea of what we did, and we do have several patent pending items, but the one that kind of keeps us in the game here is we have patented a process or method by which we use the Christmas tree and we attach an air motor, a generator, and a switch gear to produce electricity. We then, of course, have patented several other options, including putting high pressure piping, exhausting the gas after the air motor, adding filtration both before and after. So there's a lot of claims in this, but the simplest one is if you want to put an air motor attached to a Christmas tree or a hydraulic motor attached to a Christmas tree, and generate electricity or generate power, whether that be electrical power or hydraulic power, we have a patent pending that will keep us attached. Now, on the hydraulic side, or I'm sorry, on the air side, we also calculated that a 4,000 psi, 10 million cubic feet per day well is equivalent to a 10,000 foot dam. What a 10,000 foot dam could produce through one of its water motors, I guess you would say. The largest dam we have is 500 feet in height, so that kind of gives you an idea of the power that we have with one well in our environment, and we need to utilize this because it's clean. It's not green because we're not recovering anything, we're not recycling anything, but it is clean, non-emissions energy that is produced. Our goals here are to produce clean energy, zero emissions, from pressure in wells, whether that be artesian wells or gas storage wells or oil wells or gas wells. We want to produce that energy at a cost below the current cost of carbon emission fuels that produce the energy. And we want to set a goal of 15 years to eliminate coal and methane emissions altogether. Those are two things that we really want to do. Our 30-year goal is to eliminate emissions from motor vehicles and move motor vehicles to either all electric or all air or a combination thereof. And we do believe this is achievable. There is a reference slide at the very back of this presentation that has many or numerous links to what's going on within the world as far as electric and air systems. So for our goal one, this is a slide from the IEA, which is a government organization that tracks the use of fuels. And as a worldwide basis, 39.3% of the world of electricity produced is produced by coal, including a lot of it here in the United States. That needs to go away, and we need to move to more natural gas and to this new energy source of pressurized media. We should be able to eliminate that. Now, that 39% is worldwide, not just the United States. In thinking about moving into green energies, we all need to think about what is the impact. How many employees is it going to impact? How many families? And then how many families are going to be able to swap from what industry they're currently in to this new industry or new industries so that we can we don't just completely isolate one industry. In the U.S., we've got 50,000 employees in coal, so that is not a large number of people, and that should be able to be, as we roll these systems out, we should be able to handle that. On the 9.8 million employees in the oil industry, that's a much tougher number to swallow. But I am sure that as we install these systems, they're going to need installation, they're going to need maintenance, they're going to need manufacture, they're going to need to modify their wells to add inlets and outlets before and after the choke. So I'm confident that a lot of these jobs can be saved. I just don't have a feel for what the percentage of them are. But goal is get rid of that coal, the black coal slide, and let's move to something a little more clean. Here at Texas Monoline, we do not have a lot of employees. We have about 5 employees in total. But I wanted to just give you some background on our key members. So myself, I'm a mechanical engineer, former VP of Engineering and Manufacturing for Stewart & Stevenson. I was also a plant manager for Cameron, a global business unit manager for Weatherford, engineering manager for RCW, which is a titanium company, and all around pressure control kind of guy. But I had that stint with Stewart & Stevenson, which really plays a part in what we're doing now. At Stewart & Stevenson, we did gensets for GE, and these were 2 megawatt gensets with 2,500 horsepower motors on them, whether they be Detroit diesels or MAN engines or Caterpillars. And we also did turbines. So we took turbines off of aircraft and made an aeroderivative for an LM2500. And we also did landfills where we would apply water to the top of the landfill, turn on some air compressors that would suck air down through the trash, make it decay, which means it becomes methane. Take the methane through a scrubber, clean it, put it into an engine, burn it. It's tied to a generator back to the grid and make energy back to the grid, electricity. So all of this plays a part in being able to tell you or to support how we came up with these concepts. I have my engineering manager, Eric Calzona, who is a mechanical engineer as well, worked with me at Weatherford for 10 years in pressure control, expert on SolidWorks, and then all of the finite element analysis that goes on within that. I then have Kenneth Miller, who is a former Anadarko IT manager, IT expert, accounting. He also handles our marketing, accounting, and so forth. We do also have Angelica Calzason with our quality manager, and she handles making sure that we follow API, and all of our stuff is built to API PSL3, typically LU specifications. So we don't have a lot of people. We don't want a lot of people. Most of this stuff can be formed out to packaging companies and the like. What we do need is a motor expert, a salesman, which we have a salesman that's not working at the moment. Angelica is the quality manager. We needed another couple of draftsmen and a couple of service techs, which we all have. We have all these people identified. We just don't. We are not employing them at this time. Again, we would use packagers such as Stewart & Stevenson or Caterpillar for the frame or trailer, if we did it on a trailer, and manufacturing, packaging, and producing the switch gear doing the installation, startup, and providing warranty. The part that needs to be invented is a high pressure, high volume air motor. Uh, Typically, you have many people that build vane motors, rotary vane motors, piston motors, but the pressure, input pressure, is typically less than 275 psi. And so most of these things are built from castings and not forgings. They are considered low pressure, and that's because if you go to the store and buy a compressor, or if you order a compressor, typically that compressor tank is rated at about 200 to 250 psi. And so all of our air tools and all of our machines, because a lot of CNC machines use air for air chucks and so forth, they're all used low pressure. And low pressure to us is anything less than 500 psi. So a motor that can handle a 10,000 psi load, which would give you much more power, is needed. In addition, most of these use 90 CFM, and we need something that can handle, 10,000 CFM. So it's not a very difficult thing to make this. We have our own designs that we will be patenting for this in both vane motor, vane rotary motor, and in probably in piston and turbine motor as well. We are unsure of which one is going to give us the best results, but we are in the process of manufacturing those, and we could use some support, financial support to push those along even further. Why do we need this air motor? If we take a look at another report from the Energy Administration, Energy Information Administration, this is a slide from 2018. I just didn't, I don't think the 2019 slide was done when I put this up. But this is a list of all of the gas and oil wells in the United States in 2018 and what, in brackets, what they actually produced. So if we just look at the bottom right, gas wells, there are 27,500 gas wells in the high-end production area. Now, oil wells are on the left, and oil wells also produce gas, but the way that they determine whether it's an oil well or a gas well is that everything is converted to BOE, barrels of oil equivalent. So if your BOE produces more oil than gas, they're called an oil well. If they produce more gas than oil, it's called an oil well. I mean, a gas well, excuse me. So just looking at the 27,000 wells, and again, there are over 500,000 gas wells and 400,000 oil wells that are actually in production in the United States at this time. If we just look at the 27,000, they can produce over 500,000 cubic feet a day. Now, that's at various pressures. It could be anywhere from all of these would be in the over 2,000 psi all the way to 10,000 psi or even higher. That's a total of 20 trillion cubic feet per year. When we convert that from cubic feet under pressure to mechanical, using a mechanical formula of 2,400 cubic feet per kilowatt hour produced, we get 8.3 billion kilowatt hours can be produced a year. And if that were to be sold back onto the grid, that would be a revenue of $830 million a year at 10 cents a kilowatt hour just for those 27,000 gas wells. And that does not consider if you can expand that number due to a bigger moment arm within the vane motor or the piston motor or whatever type of motor you're talking about. It also does not take into efficiencies if we were to run turbines at 18 to 20,000 RPM. So anyway, that is a $1 billion industry because that's only the top 27,000. That's, you got almost a million wells that you can do this with, and the oil wells even have greater potential than this. So this is, worldwide. Who can calculate what this could be? This is something we want to pursue. We have 2 or 3 motors in mind. We have drawings and SolidWorks and step files, and we're continuing to calculate, and we're just about ready to pull the trigger to go ahead to manufacturing, so that we can do some test wells for BP and for Chevron. Doesn't look like it's going to take as long, because we've been doing a lot of the engineering already. So while this timeline shows a 12-month period for for sales, it really, now we're probably down to 8 months to do this entire job, and we're going to continue, with or without funding, we're going to continue to pursue this and get our field trials done. So that's where we're at with that. In our proposal to several venture capitalists and all, and we have not agreed to anything with anybody yet. What we'd like is a $6 million startup, so that we can continue to operate, and there's a breakdown of what our budget kind of would be, and what the electric sales would be. And while we test, we can build 3 or 4 different prototypes and see which one is the best and make that happen. Now, after that, the next part of this is the setup of the company. And how are you going to do business? You could certainly just sell these units for a profit, but I don't think that's what we really need to do. I think this is more of you rent the units from us, and we split the electrical production sales with the oil company and the electric company that's allowing us to put it back to the grid. So I think you would make a lot more money not as a manufacturer, but as a service company that's using someone's fuel, someone's gas or oil coming out of a well, and putting it right back into the pipeline that it was going in anyway at the exact pressure that they wanted it, and just removing the choke and putting in our unit and producing energy. So that all needs to be discussed, but this is, again, worldwide. This may be even $1 trillion industry. It has many, many potentials. That's up for discussion. I did include a few just minor points for engineers that want to try and understand this a little more. So this chart here can be interpolated up to whatever pressure we need to be at, and the lines continue to be the same. There isn't any hidden secrets in production of vane motors, whether they be air motors or hydraulic motors. We've done some calculations on what size the motor should be, and again, I think if we talk with our ear engineers, or as we develop this, we can all sit down and have a good engineering discussion. Possible uses and cases, of course, well pad to grid, which is what we think is one thing. We also have gas storage to grid. We have a couple charts on that if someone would be interested in that. But there's also pad location. For instance, if you're offshore on a platform and you hook this into your gas production, and the gas production is still going through all the pipes and down the line and still getting sold for the same price, you can produce electricity out at your pad with use of very little gas. You're not really using the gas, you're using the pressure of the gas, and you can power your entire platform without having to bring fuel out every week for your motors and engines. So this would be a great field use for that. We also have areas like Mozambique and remote areas that actually have wells but have no electricity. And as these indigenous people need power, you can create a grid just by the use of the decompression of the fuel in the middle of the jungle or pretty much anywhere, and not have to run miles and miles and miles of cable of electrical lines to give them electricity in modernized cities. We can do local industry, municipalities, if there's a well nearby. Military bases would be wonderful for this. Just box that off and put a few people to protect the well and bury the lines to the military base in Afghanistan, and bam, you've got power for the whole thing, and you're not moving fuel with tankers for for every week and spending all that money. So this can be a big, huge money saver. Okay, so what do we need? What do we want? We want some funding. We want some financial support. We need about $10 million for 2 years. Now, that does not include any revenue that we would have coming in, and I think we'd have more revenue than $10 million coming in by that point. We need partners. We need prototypes and field trials to be completed. We need the setup of a business. We need, this is going to be a billion-dollar company. We need staff, administration, we need accounting folks, financial, legal. We need to continue our patents. We need sales. We need, everything that you need within a business is needed. And then I think we need a strategic team, a focused war room kind of place that we make sure we're not missing anything. And we discuss the possibilities of how do we want to go to market? How do we want to sell? What image do we want to create? Who do we want our partners to be? First, second, third. So these are all questions that I think, as you create a corporation, you need to be aware of. Again, the reference page, you really need to look at some of these things. They've got cars now that can go 162 miles on 1 tank of air, and you can pressurize that bottle of air for $2. So calculate the gas mileage and the cost per mile. It's just amazing. The Germans are doing some great things. Australia's doing some great things. And I have a feeling we're out of touch here in the United States with what's really happening in a lot of parts of the world. To wrap up, again, $1 trillion market. We need to develop one piece of equipment, high pressure air motor. I think the high pressure hydraulic motor probably already exists. We need customers, partners. We need to identify them and start signing CAs and getting everybody in place. We need help with moving the provisional patents to actual utility and or method patents. We need to be telling people that we can produce clean energy with no emissions by the use of this. And I have reached out to Senator Ted Cruz for possible government grants on this. And so all of this is needed for funding. I hope this was informative for you. And again, my name is Todd Travis. Here's my cell phone number, my email address, and I appreciate you taking a look at this. Thank you so much.